Is your SQL query slowing you down and you can't figure out why? Could the problem be hidden in your where clause? Today, I'll show you how functions like trim could be secretly sabotaging your performance and what to do instead. When you're filtering data with SQL, the way you structure your where clause can have a massive impact on performance. For example, let's look at two ways to filter rows. First, we can use the like operator to match operations. And second, we could use functions like trim or left or right to manipulate values before comparing them. But here's the thing. Using a function in your where clause like trim can slow things down considerably. Why? It has to do with how SQL executes your query. SQL has to apply that function to every row in the table before it even attempts to process the filter. This process not only adds overhead, but also prevents the query optimizer from using indexes effectively. Let's compare that to using a more direct operator like. When we write column, like, and then value with a wildcard, SQL can utilize the indexes much more efficiently, especially if the pattern doesn't start with the wildcard. Next, we're going to take a look at some real-world examples that I'm going to walk you through within Azure Data Studio. So let me show you an example so you can see the difference clearly. Imagine you have a table with millions of records. In this case, I've downloaded and installed the AdventureWorks dataset that you could get readily for free from Microsoft. So the first query, we're using a function in our where statement. And you'll see that we're taking the left 4 characters of the first name and we're looking for John. So anybody who starts their name with John, Jonathan, Johnny, John, whatever the case might be. The second statement does really essentially the same thing, but we're not using that function. And instead, we're using the like clause and we're using a wildcard. Keeping in mind that for SQL Server, the wildcard is a percent sign. So comparing those two, let's see what the output is. You'll notice when we look at the output from running those two queries that they have the same output, the same eight records. Let me see if I could get this a little smaller for you so that you could see the whole thing. So you'll see that the output for both of those queries that we ran are the same. They're identical for both of the data sets for both of the queries that we ran, regardless of whether you're using the function, the left in this case, or you're using the like and filtering with the wildcard. Now, all that to say, keeping in mind that every time you use a function in a where clause, SQL has to run that function for every record that it returns. However, as a data engineer, if you know that there are scenarios, for instance, where data that you may be pulling from may have some trailing spaces, you need to do that data cleansing up front. Don't require your analysts, your data scientists, your other business analysts to have to use things like trim. Trim shouldn't be needed once that data is already in your database. You should be trimming that data as you're putting it in. So that should be part of your ETL process when you're loading data. Things like trim, and if there is very common ways that you're filtering for things or searching for things, for instance, there's been plenty of times when for email addresses, I've delimited by the @ symbol so that you had the root of the email address in one column, and then you have the domain of the email address in another column. Because there's definitely times where you have users that are searching for domains. You may have somebody that's looking for all customers that are part of northwindtraders.com, that have a northwindtraders.com email address, or maybe even that all have a Gmail address. So if you know that those things are going to happen up front, and you know that that's valuable information to transform into, then make sure that you're processing that up front, that you're using the right functions up front as you're loading that data into SQL. This example is a little bit more complex and does probably take you up to an intermediate level of SQL. So if you're not ready for it, I absolutely understand, but it is super valuable and I wanted to cover it with you today. It really involves several different things put together that we've been going over the last several months. It has things like pivots. We're using a row number, so we're using the window function. We're using a special type of join called cross apply that I'll walk you through what that is. So we're really adding in all the things that we built up to up until this moment. This is a very realistic data engineering ETL scenario that you're going to run into. So in this case, we're again still the same data set, really still just looking at John here, all of our different types of Johns, and splitting out the email address at the @ symbol, so that we have our domain in one column and our local email part in another column. So let me walk through what we're doing here. I'm going to start with the cross apply. So this is how I'm going to explain cross apply. Think of cross apply like a smart loop or a for each statement that works on tables. So basically what this is doing is it's saying that for each record in this query, I want to do this. I want to apply this specific set of logic. And in this case, the logic that we're applying is we're grabbing the value and the row number. We're creating a row number, right? This is our window function. Row number, oops. This is our window function here. Row number over partition by email address, order by our nulls, and then as row number, right? So that's all we're doing here is we're creating row numbers so that so that we could pivot it, right? And then we have this string split function. So basically what the string split function is doing, we'll see here, we're ambiguous name email address, but it understands what it is. The table valued function, basically it's saying take the email address, split it at the @ symbol. Now if you had some strings that were in a column and they were divided by something else other than the @ symbol, maybe they're divided by pipes, which are the vertical bars, then you could put that in there. If they're separated by dashes, you put that in there. But it'll split whatever that string is. Now the problem here is that when it does that, it's going to split it into a very normalized view. And so it's each row is going to have a different value of that split. Now, we don't really want that, right? We don't want to multiply our 8 times 2 because it'll split that into 2 and give us 16 different records. We still want just the 8 records. So what we're going to do here is we're going to add the pivot function. Now, pivot is something that we've gone over in a past video. Be sure you check that out for more detail about what that pivot function does, including how to create some dynamic pivots. However, basic syntax of a pivot function. Pivot syntax is we'll say pivot, very simple, and we're going to use our parentheses. We're going to say max value, so whatever this value is, right, for row number in 1 and 2. 1 is our first half of our email address, and 2 is our domain piece. And then we're going to have our where statement at the very end of this. So not super complex. Now, we do have 1 and 2. 1 and 2 don't mean anything as far as field names go, so we want to alias those. 1 is going to be our email local part, so it's our, for example, my one would be chris.gamble, and then my two would be at gambilldataengineering.com, right? The gambilldataengineering.com would be my two for my email domain. So here, when we run this, we'll see that we've got our 8 fields, our 8 column, our 8 records, and we have it's split it by our local part and then our email domain. So again, this is really, if you know that somebody's going to be searching for a specific thing very commonly, if they need to use it as a join criteria, those types of things that you know are critical to the business to have, be sure that you're transforming your data to meet the needs of the business. So the next time that you write a query, think twice before using a function in your where clause. While these functions have their place, using them unnecessarily could cost you in terms of performance, where instead, aim for using operators like or direct comparison to keep your queries efficient. And again, if there are things that you know are critical to the business that you could do up front in your transformation during your ELT or ETL processes, be sure that you're processing those. Using functions like cross-apply and string split will go far in your career in understanding how to set up your tables to meet the needs of the business. What's your biggest challenge when it comes to writing SQL queries? Let me know down in the comments. It will help me to develop my curriculum as we go forward to help better serve your needs. If you've missed our previous SQL tutorials, be sure to check those out. And if you've missed our Python tutorials, you really want to check those out. I hope you've enjoyed our video. Have a great day.